Okay, so welcome to the Crossy Road Rip-Off Game tutorial series. In this first video, I'm going to just try and go over the basics of us setting up Unity and getting our projects ready. And I'm going to be throwing a lot of new terms and new words at a bunch of you, unless maybe you're all Unity professionals, I don't know. But I'll try and explain them as I'm going. And if you do have any questions, just, let me know in the video chats, the lessons, or actually when we're in class. And if you do have any problems, again, you've got my email, or you can contact me on Teams or get in touch with me any which way you want to. But anyway, let's get started. So all I've done is I've literally opened up Unity and I've created a new project called Crossy Road Tutorial. And that's it. That's it, not done anything else. It's a 3D project. So for now, just get yourself to this point, new 3D project. And once you're in, we can see in our scene, in our hierarchy, we have two things. We've got our main camera and we have our directional light. So this is what's going to make objects look 3D. So your basic light and the main camera, that's obvious, it's a camera. If we click on our camera though, and look in our inspector, we've got a bunch of stuff. We've got the skybox on by default, which we'll keep. So we can see these two things, but let's also go into our edit, project settings, and player. Edit project settings and player. And this is where we can actually set up more information about our game. So let's make a HD game. If we were making a mobile game, we could, we'd want it vertical rather than horizontal maybe. But we're going to be making a windowed version of this game, and we're going to make it HD. So HD is 1920 by 1080. And I think the rest will be fine for now, we don't have to worry about that. But this is also would come for our input manager, our axis. So setting up our controls. And again, we're not going to worry too much about that. For now, we're just going to be using the basic control, which is just left mouse click. So we're just going to be using left mouse click. And if we want the left mouse click, we can see it's fire one, which can be controlled by either mouse 0 or left control. There you go. Good to know. And this is our game view, not much going on. Our scene view, again, not much going on. Let's start blocking out our scene. So let's go to plus and create ourselves a plane. And let's reset this so it's at 0, 0, 0. And considering our camera is behind it, looking at it this way, what I'm going to do is I'm going to navigate, fly around, and I'm going to make this really long by hitting R and dragging it out and move it up a bit as well. There we go. And you know what, I'm going to move my camera up a bit too. So now it looks like we've got this nice long road ahead of us. That's going to be our main playing field. And we're going to need a character as well. So for now, we're just going to use a 3D object, which is a cube. And I'm just going to reset it. So it's at 0, pull it back, lift it up off the scene a little bit. Pull my camera back a bit. So you see we've got this preview, and we're just going to try and get it looking a bit nicer. That should hopefully do it. And it's important to keep organized as we're going. So let's also rename the things in our hierarchy. Flow path. Notice I'm not using spaces, and I'm using a system called camel casing. Now technically we can use spaces in a hierarchy, but it's good practice just to not. So we're going to be making sure we use that camel casing, no spaces with capital letters for each new word. And we'll call this player. Cool, there we go. Looking good so far. Now what we want is every time we click, we're going to want this guy to jump along the road until he gets to the end. Oh, endlessly, or however we decide to do this. Now is the part where we're going to organize our work, because again, organization is important. So in the space down here, this big space at the bottom, let's right click and create some new folders. We'll call one scripts. We'll call one what else we need? We need models. We might need audio. We might need textures. In fact, we will need textures, so there's scripts, textures, scenes, models, and audio. I think that's pretty much all of it. And you know what? Now seems like a good time to save it as well. So let's hit File, Save. Here's might ask you to name your level. It might not. I'm using Unity 2019. And if we're going to be moving your work back to college or not, it would be best if we sort of try and match up version numbers, but at the moment I'm not too sure what version number is on the college computers, so we'll worry about that later. But I will show you at the end of this video how we can export our work to move it back and forth. Okay, inside scripts, what we're going to want to do is right click in some space and create a new C# script, which we will call player movement script. And I'm just going to reiterate this at this point: no spaces. If you put a space in here, you're gonna have a bad time and it's not going to work. So no spaces. Now when I double click this in a minute, this is going to open in Visual Studio for me, and yours, mine, I can't remember if Unity comes with Visual Studio. So if it doesn't, we just go to Edit, Preferences, and then click on External Tools, and you'll see here, if you've got Visual Studio, it should open there. If you're using an older version of Unity, it might have something called MonoDevelop. But if you've not got anything, then what you'll need to do is go to the old Google. Interesting. And you'll want Visual Studio Community. Now, Visual Studio Community is a free IDE, an integrated development environment. And just click it and download it. Boom, job's a good one. So once you've got that, and it's all downloaded and set up and run, just go to External Tools and then set it up for Visual Studio Community. Okay, we are ready to open and start writing our first script. Yours might ask you questions, just pretty much say okay to it and tell it what it wants to know until it's ready and you're ready. Cool. So once we are inside of our script, we got a couple of key parts. We've got our APIs at the top, which we're not going to worry about these for now. And then we've got the name of our class, which is player movement script. If you have a problem in Unity and it gives you an error, it could be a case of you put spaces in, or maybe the name doesn't match. So if this name here doesn't match this one, again, you've got a problem. So you just need to make sure that they match. Mon behavior means it derives from Unity. And then we've got our main body. So you will come across mistakes. You will make mistakes with this part. It happens. I make mistakes. Everyone makes mistakes. Just usually it's a case of make sure you're working between these parentheses. Now might be a good time to draw a diagram. Let's do it. Do it. A diagram. Okay, so imagine this right here is your script. I'll use this one. Now, this script contains everything. It contains absolutely all of your code. But inside this this is your class, right? And this is why you see it starts here and it starts there. So think of it like that. Now inside that, inside this circle contains these things, your events. Now these events also have to have their own circle. So at the moment we've got two events. We've got event tick and we've got event start. Now event start is going to fire once right at the beginning, and event tick is going to fire constantly. Now we've only got two, but you could have loads and loads and loads of these all in the same class. But now inside this, whenever you write your code for your start, it must all be inside this circle here. It must all be inside this circle. If it's outside of this circle, if it's in this space here, you're going to get an error. If it's anywhere but inside there, you're going to get an error. So inside there, you can also have more parentheses inside these and make mini circles, but let's keep it simple. So always write inside the body. Inside the body. Now for the entire class, we have this space here, and it's on line 6, and this is where we declare our variables. Now going forward, we're always going to use this space here. We're just going to come to the top, we're just going to hit event a bunch of times and create our variables. Now variables are just a piece of code, a container that stores a particular type of information. And we'll have discussed these in class, and we'll continue to discuss these in class and build on our knowledge of it. So I'm not going to go too deep into the theory here because we will be discussing that in class. So inside here, what we're going to need to do is we're going to need to access the player's physics system. Now Unity has a physics system that's referred to as a rigid body. If you apply a rigid body, it means you've got a physics system. In fact, let's move this out of the way for a second and let's go back to Unity. And if we hit play, nothing happens because our player doesn't have a physics system on it. It's got a box cloud though. That's cool. So what we need to do is go into Unity, and then we're going to go to physics. Sorry, into Unity. Go into add component, physics, not physics 2D. We're making a 3D game, and we're going to click on rigid body. Now this gives us a bunch of options. So we've got mass, which is sort of weight. We've got gravity, which obviously we want to use gravity. And then, I don't think we need to worry about that for now. But if we hit play, we can see it drops. It drops, and it's good. Just going to move my camera back a little bit more. It drops, and it hits the floor. We've got physics. We've got collision, and we've got physics. Isn't that awesome? So if we come back to our script now, we want to be able to speak to that rigid body system, the physics system. And the way we do that is by talking to it, by saying, hey you, rigid body. But we're going to write a shorthand way of doing this. So every time we want to speak to it, we only need to type in RB. And the way we do this is by making a variable called a private rigid body, RB, which is just short for rigid body. And in the start section, as soon as it runs, we're going to say RB is equal to get component. Now I'm going to write all these out, but Visual Studio does have a predictive system in here where it tries to predict what you're typing, which is really nice. If you don't have that, just double check in Unity, like I said, in the external tools, that you've got it set up for Visual Studio. And when you set up Visual Studio, it might have asked you if you're working on a C# project. You are. And if you're not getting the predictions, I'd just save everything and just restart, and you should get them then. Or you can just type it all out manually. Anyway, we want to get component, and then inside there it's going to say what component do you want to get. Well, I want to get the rigid body, and don't put a 0 in there. In fact, put a open and close brackets, and a semicolon. So essentially now, really, all we're doing is every time we type in RB, because we're going to be typing in RB, it's kind of just going to run this line of code here. So it's just going to get access to our rigid body every time we run this. And remember, when we're telling a command, telling it to do something, we end with a semicolon. So now we want to come to our update section. And the first thing we're going to do is we're going to change it to a fixed update. Now the reason we're changing it to a fixed update is because update runs every time your computer refreshes. So one of you is sat there right now with an amazing top of the line spec computer, and every time you run an update, this is going to fire the code, and your super fast computer is going to fire the code, I don't know, let's just say 100 times a second. Whereas someone is sat here right now on a laptop, not so good, and their fixed update, their regular update might fire the same code only 60 times per second. And those extra 40 frames can make a difference. But by using a fixed update, it's going to run it at a set interval, which means it's just going to work more smoothly. That's the long and short of it. Okay, so in fixed update, what we want to do is we want to look for a control. So we're going to say if the player, if open brackets, if input dot get button, if input dot get button, now we need to say what button is it, so I'm going to open some more brackets, and I'm going to say speech marks fire 1. If input get button fire 1, then I'm just going to press enter and open a curly bracket and press enter again and separate them. So this right here is the line that we've written. And if you're wondering again where I got fire 1 from, it's in your project settings or preferences, project settings, input manager, fire 1 is this. So we're just writing fire 1. We could write any of these things and it would relate to the controls. So if fire 1 is pressed, to make sure this works, we're going to use a debug.log. Now we're going to be using debug.log a lot because it's the best debugging tool and the way of just finding out errors and making sure things work. So we're just going to write debug.log hello world and let's hit save. I always hit save all and jump back to Unity. Now this is compiling, which means it's turning that code, breaking it down into a code language that the computer understands, such as like binary. So we won't be able to play for a second, but once it's compiled, we can hit play and it's not going to work because we've got to attach the script to the player. So we're going to get our player, and we're just going to drag it and drop it, drag and drop our script on there. Now we can see we've got a script in our inspector. So now if we open this up, press play and we go to console, every time I left click, you can see it's printing hello world, a whole bunch. Look at that, printing a whole bunch every time I click. Isn't that awesome? Isn't that just awesome? Cool. So now we've got that working and we know it works, we can go back to our scripts. Now when we're not using a line, if you don't want to delete it, you can just comment it out by putting 2 forward slashes. Forward slashes just makes it a comment, makes it easier for the person to read, the program to read, such as these, but you don't have to, like I just got rid of those. The computer knows it. That's purely for us humans. Right, next thing we're going to do is we're going to speak to our rigid body. So we're going to say rigid body, have some force. So we're going to say rigid body, have some force. Now we're working in a 3D game. Well, that's no sketchbook. I should have kept this open for my sketches. And because let's just say this is our path, and we've got a cube here. This cube can go in 3 directions. It can go horizontal, vertical, or even X, Y, and then Z. So we need to tell it 3 pieces of information. We need to tell it the X information. We need to tell it the Y information. And we need to tell it the Z information. This makes up our vector 3. So if we go back to a script, we're going to open some brackets. Now if we had a vector 3, if we'd made one as a variable, which maybe we will. In fact, well, let's just write it out first. So let's just say hypothetically we want it to go horizontally, none. But we do want it to jump a little bit. So we're going to say, I don't know, 10. And then we want it to also go forward a little bit too. So let's also say 10. And then I do semicolon, hit save, and go back and let's give it a test. And now every time I click, I mean, we can hold it, but we'll fix that. You can see we are moving. So that's working. It's not giving us much jump, but we'll come back to that in a second. So if we want more jump, we just need to increase the Y and maybe set that to, I don't know, 100. And we could test this. But what we're going to do instead is we're going to make a new variable. Now, before we declared this one as private, which private just means only Unity is looking at it. We don't need to do anything extra. So with it, only this sort of singular class is looking at it. But if we had a public variable, it means it exposes it to Unity and we can edit values directly there and other scripts can edit it and that kind of stuff. So we've got this public variable, which we will call move vector. Oops, sorry. Which we need to declare first as a vector 3. And we'll call it move vector. Now, here is where we could sort of set it. But instead, what we're going to do is we're just going to leave it blank. And we're going to delete this out. And I'm just going to type in move vector. And hit compile. Now let's go back to Unity. And if we've got our place selected, and we scroll down our inspector, just this gadget over here, this inspector gadget, we can see this move vector, which has got 3 values of 0, 0, 0. Because we've not set it, it has a default value of 0, 0, 0. Now we were just messing with this, so we're going to try 100, and maybe we'll try 20. Okay, that's way too high. But we can edit this while testing. 40 seems a lot better, doesn't it? Maybe 20 is still too high. So maybe we set that to 15. I don't know. That's up to you. Mess with this a little bit, get your variables set up right. But notice once we come out of play, it defaults back to what it is. So make sure you keep note. I think we said about maybe, I don't know, 14, 15. Okay, the next thing we're going to try and look at, we're just going to edit. Once you're happy with those, feel free to pause this video at any point, is the input system. So we typed in if input get body. Now don't type this in, I just want to show you this for a second. If input dot get button. Now you can see mine's predicting 3 things. I could write get button, which returns true when the virtual button is identified as being held down. We've also got down, which I'm hovering over, and it says returns true for the frame the user's pressed the button. And we've got up, returns true for the first time the user releases the button. Now, let's imagine you're playing a fighting game, and you're building up a Hadouken projectile. The more you hold the button, the bigger this Hadouken projectile is. So what you might do is, upon being held down, you might start charging the effect, and then upon the release the button, you would release the Hadouken and it would shoot across. So we can use this information to make our code a little bit better. So what do you think we're going to put here? Feel free to get ahead of me. Let's try it out. And now, for the sake of test, I'm going to bring back my debug.log. Save it, compile, and go back. Now, what I want to see is every time I press it, it only prints once. It is, but it means I've got to make this number a lot higher. Let's try 200 and try 50. Now it doesn't seem to be working very consistently for me, but I'm going to assume that's because I'm recording my screen and it's got a lot going on. We could also try it on up. We could try it on up, because that didn't seem to be working very consistently for me. So I'm going to try it with up. And again, this one's up to you. It's your game. You don't have to make yours the exact same way as mine. So you pick one that you think is going to work better for you, whichever system you prefer. Same sort of thing every time I click. It's not actually registering. Let's try. Was it left control? I think it was. Yeah, it doesn't seem to be working as consistently. So actually, I'm just going to go back to having it how it was. So I don't know if it's just my computer being a bit slow and not recording very well. So I'm just going to leave this as get button, fire 1. Awesome. Awesome. And let's just make sure that we've got values that we're happy with. And it sort of works. See how it's not consistent now? But we're gonna fix that in a minute. We're gonna fix the lack of consistency in a minute. A quick thing to note, if we sort of press it a lot, you see how the thing starts rotating. I want to stop it rotating as much. And the way I'm going to stop it rotating as much is I'm going to increase the angular drag. Now this is going to affect the physics of how it actually moves. So I'm going to set it to 0.8. Give it a test. It's made it a little bit firmer. We've still got a bit of wobble on it. Let's try 0.9. So I'm also going to stop it from forward flipping. So I don't mind the left and right wobble. So if I go to constraints, I want to freeze rotation on, which one am I going to freeze it on? I'm going to do a test by going to my rotate tool and paying attention to my rotator. So I don't want it to rotate like this anymore. So I'm going to lock the X rotation. So you see how we've still got a bit of wobble, but it's not forward flipping anymore. I've dragged that angular drag way up now, and it's just barely rotating. So it's up to you to try and find a number that you quite like and that you're quite happy with. And I think for the first video, that one's probably gone on quite a while. So it seems like a good place to stop it. The next thing we're going to do is limit how much we can move. So we can't keep double jumping because you can kind of just jump away. And we'll probably get the camera to follow it. But for now, that's a lot of information. Good work, guys.